Okay, great. Everyone, Nick Pander again. I'm with AMD. I've been at AMD since January this year. I came from a protocol company which was friendly with VMware. Where's the VMware guy in the room? Oh, so, I don't need to mention who. Prior to that, I was at NVIDIA for quite some time in the workstation group. Have extensive workstation background over the last 20 years. So for me, this is really exciting, bringing GPU technology and virtualization solutions together and really taking this to the next level. Very, very fast. I'm local to Southern California. I live here. So I knew enough to plan for the traffic. So I got here way too early. But I have a worldwide role. So I cover business development for our GPU solutions for data center, for anything to do with VDI, desktop as a service, and remote graphics. I have a counterpart who covers compute in that same environment, so using GPU type compute functionality. Any questions at the end, find me. I wanted to give a quick background of who we are, AMD, because we get this a lot. AMD, well, aren't you the CPU company? Just give you a level reset really fast on who we are, because does everyone kind of know what we do in the graphics space today? Okay. Well, there might be some things you're not aware of. So we're delivering modern relevant technologies for computing. We actually do the CPU and GPU inside PlayStation 4. And I'm bringing that as relevance because this helps us push our GPU core roadmap, and it helps us push our I/O roadmap to where we're going. We also do the CPU and GPU in Xbox One. So both the mainstream game consoles we're doing the technology for. Key thing there, that pushes us towards bleeding edge technology onto those the GPU core and the compute type cores. The group that I'm in focuses on professional graphics. So we're taking that GPU technology that's coming in the consumer space and we're leveraging that into the professional space, going after everything from digital content creation to MCAD and PLM type markets. And that's a growth market for us. This was at a previous company called ATI Technologies had a product called FireGL, and some of you may remember that product years ago. This is basically a reboot of our professional graphics effort over the last 2 years, and we're clawing back market share, and we're doing well in the market. So you're going to see more of us. You're going to see platforms coming out from OEMs that are going to start including FirePro more prevalently, and you're just going to see more visibility coming on that. Why that's important is, as people look at their physical platform GPU choices, they're going to want to know, okay, can that same technology bring me into my virtualized ecosystem as well? A few quick things as well. We just launched this W9100. I want to bring this up because I have discussions with some of you guys before on 4K resolutions for oil and gas and visualization. This is a bleeding edge card on compute performance, also displays. It'll support up to 6 4K displays. Crazy nutty performance. We're already getting requests from customers in the oil and gas space and other visualization space to say, I want to remote graphics this with a protocol, or I just want to put it into a data center and I want to direct pass through it to a virtualized environment. So that's one area on really high end for us. Another key thing that's happening in the market is, you guys all know about compute, you know about CUDA on the NVIDIA side. There's been an initiative over the last few years to do an open standard for compute. OpenCL, it's us, it's Intel, it's Qualcomm, it's a whole stream of guys who are pushing this standard. And what we started to see in the last 12 months is all of the tier 1 packaged applications are supporting OpenCL, and some of those have actually made the commit to say 2015 and beyond, we're only going to support OpenCL. We'll keep our CUDA investment where it is and fix bugs, but we're only going to invest in new code on OpenCL. So that's going to be a differentiation that you're going to see in the market. Of course, there's boutique applications for engineering and oil and gas, like 2 people in their garage who are on CUDA and they're not going to move for a while, but we're seeing mainstream applications are moving across to OpenCL. And what we saw in that happening was Apple picked Fire Pros for the Mac Pro purely because Apple is very much NIH in that they're going to want to make sure any technology they push is their standards or standards that they bless. So what you're really seeing here is Apple pushing a solution that is using pretty much open standards. Bringing us then to what we discussed on Moonshot, just giving you relevance of technology, we're also enabling things like the APU technology. APU is basically x86 CPU and graphics and I/O mixed together into one chip. So we're starting to see those type of engagements. So specifically my role is taking the FirePro products. We have this technology badge called Sky Technology where we're doing the software stacks for VDI, DAS, application virtualization, and remote graphics. And what we're really bringing to the market is, again, GPU choice, not lock-in. We want to make sure the use cases that are getting ignored today are going to get addressed. So taking it and peeling it back a little bit more from it just being product specific, one thing that I see that's not addressed in the market today is that there is not a one-size-fit-all strategy to GPUs. There's going to be different use cases for different type of GPU technology. There's also going to be support needed for lower and mid-range type 3D application use cases. They're just as important as high-end. You want to make sure you have a top-to-bottom solution for GPUs, and it works with the hypervisor, works with the remoting solution that you have today. And key thing as well is cost effective. There's nothing worse than going into a customer, having them look at the full total on cost of going to a current GPU platform and them killing that project in the middle, or just looking at the scalability cost to bring more users on and not committing to a second phase of that. Key thing we want to do is we want customers to move from dedicated workstations, because there's huge benefits there, right? Security, manageability, lowering downtime, disaster recovery, flexibility, and performance. These are benefits enterprise customers I go into. I'm talking large automotive, large aerospace guys that I go into are pushing on, but when they look at the negatives of the current deployments that are out there and current technology, they just say, I'll just stick with what I have. So we want to work together with partners like you to make sure the customers are well armed with information and there's good knowledge on what's the right solutions. And some of those solutions will come from us, some of those solutions will come from other people, but we just want to make sure the community as a whole has a better understanding of GPU technology. So what we're doing with XenApp today is, with FirePro GPUs, our goal was really deliver cost-effective GPU technology. Differentiate the board form factors, so instead of having to find specialized servers to put GPUs in, make it go wider across a larger range of servers, and then ensure mainstream XenApp GPU needs are met. Architecturally, it looks the same as it does with other solutions. We're basically taking a FirePro GPU, putting our native FirePro driver for Windows Server, and letting everything else abstract through. You get OpenCL 4.3, DirectX 11, and you do get compute via OpenCL 1.2 in that environment. So this is, I'm purely talking about XenApp right now. I'm going to talk about other solutions in a moment. Oh yes, it'll work. Yeah. So it can be bare metal, or you can use Zen Server and do direct pass-through, or you can use vSphere and do VDGA pass-through. It'll work fine with that. Yep. So really, what we want to do is deliver remote office users and mobility users essential applications that may not require a dedicated VDI type delivery, just using XenApp, and also address the needs of users and reviewers in CAD, PLM type markets where you have users that are more reviewing data or they're viewing data. Example could be, I'm a purchasing guy at an engineering company. I'm looking at the CAD data. I'm not necessarily contributing to the CAD data, but I want to run that certified application. We come across a lot of engineering customers who go off and use standard Radeon cards, our consumer cards, or standard GeForce consumer cards in those type of environments, unsupported. And what they're looking for is, I really don't have to have those on a workstation class solution, but give me something that at least is good enough performance to run those applications. So XenApp packaging those applications is a great option. And then enabling also then lightweight type CAD users or PLM type users or engineering users so that they can use XenApp as a mechanism to get access to the applications and leverage a good scalable GPU on the host side, but not have it be tailored for a high performance use case only. And the application vendors we're working with today to certify ISV content on platforms like XenApp. We're working with Autodesk on AutoCAD and Revit. We're working with Dassault and CATIA, PTC with Creo, Siemens with NX, and also Dassault with SolidWorks as well. Key thing here is we're rolling out a certification program for all these platforms, and we're going to do that in conjunction with getting Citrix Ready certification with our OEMs as well for those platforms. So that's kind of a high level of XenApp. I'm going to talk about what we're doing in the other space, but I would love to get your feedback for GPU and XenApp. What do you guys feel is missing today in that space? What do you feel like is not getting addressed by the vendors today? Okay, so we have Dell today shipping on R720. We have other platforms that are going through certification right now. Can't talk, but they're about to go through. So we can support on the Dell R720 up to 4 of our single slot, because we do something unique, and I'll talk about hardware in a little bit, but we do single slot GPUs as well that just take up mechanically a single connector, single width slot. You can put up to 4 of those, 3 to 4 of those in the R720, and then we have a double width card with more performance that you could put 2 of those in. What we're seeing, it's so user-centric, and I'm actually working to get a XenApp white paper out the door on specific applications and densities, because it's so app-specific and use case-specific that you can't just throw a blind number in there, or take an S7000, you can go do 10 users or 20 users or whatever. It's so arbitrary on how big are those data sets, how, what is the use case. I got one automotive supplier today, ironically, who's running software-based graphics on CATIA, and I said, are you insane? He goes, for my under 100 meg models, works fine. Why would I, and it's not certified, it's not approved. If he puts the support call into Dassault, they're not going to take the support call, but he says it works for me. So there's use cases where it's difficult to pull down performance, but we're going to put a best stab at it on different use cases within the applications and make a stab at where we see performance coming in. So that's something we're looking to get out in the next 60, 90 days or so.
Is there a quick resource that shows which parts specifically that are certified
TBD. I'm working with Dell to get that on our certification list. So within the next 30 days or so, we'll get Dell up, and then we have a certification page. We have a website, fireprographics.com. That's going to get updated with latest certified hardware. Nice thing in, because it's XenApp sitting on top of Windows Server, we have WMI metrics where you can look at the GPU performance. We're looking at, we have products that are coming out of our mobile lineup where we can do really creative things with power consumption. We're looking at multi GPUs with the mobile type chips. So instead of having one really beefy GPU, maybe having 2 mobile type chips on there, and those things can clock down really low. They can pull the power performance down. So in addition to what we're doing with Moonshot, where we're doing very low power on a cartridge model, we're looking at very scalable type solutions, leveraging all that power saving features we have in mobile, putting those into regular server type chassis as well. Yeah, a GPU is a, you have to have the performance there to render, you have to have the performance to deliver. It's a mathematical power equation. There has to be power there to drive it. We're going to continue to improve on power.
What's that?
We're going to continue to improve on power. Every generation we get better and better on power as performance goes up.
And many people don't plan.
Exactly. I mean, this isn't one of those things where you can take a GPU from any vendor, put it into a server, and it's going to work. You want to make sure that server vendor certified the platform for power consumption, and it's a validated solution on their side. Okay, I'm going to jump into other platforms here real quick, just to give you a high level of what we're doing there, and then I want to just have an open chat at the end. So on the VMware side, we're doing shared graphics. That just started shipping with vSphere 5.5. And again, just as you asked, the direct pass-through of GPUs for Windows Server, for XenApp or RDS use cases, we support that today. And then we have VDGA coming out for the VMware platforms. We actually work perfectly with Xen Server for direct pass-through, but I'm working with the Citrix team on our APIs being supported for the Xen desktop HDX 3D Pro agent, and we're working with Citrix to get that done. So at some point we will have HDX 3D Pro support. We have a API suite called RapidFire, which is available to vendors like Citrix and VMware that gives direct access to our frame buffer and gives a bunch of other API features like turning off the cursor rendering and letting the receiver app do the cursor rendering instead, so that you don't have dual cursors flying around in a GPU use case. So we're going to continue to engage with Citrix on that. On the Microsoft side, we support RemoteFX and Hyper-V. And then, of course, the GPU-accelerated RDS works fine today in those type of environments. Yeah, Hyper-V is bare metal today. Sorry, RDS is bare metal. Yes, it's bare metal. Yeah, sorry. Hyper-V can be virtualized, direct pass-through. You're right. RDS is bare metal only on that. Okay, giving you a snapshot of two of the cards that you're going to see in most of our OEM configurations going out, the S9000, S7000. S9000, it's a single GPU, it's pretty high performance. An S7000, oops, sorry, S7000 is a single slot GPU. That means in the form factor of some of our competitive solutions today, you can have two of these GPUs and we'll match performance of that competitor solution with two of those GPUs taking up two slots. S7000 is very cost effective. So for those XenApp type deployments you're looking at where you're going to bring graphics in, but the customer's really budget constrained or they're leaning towards software rendered, but that may not be the right approach, S7000 is a good value option to come in there. Coming from the bottom, if you look at that graphic space on the pyramid, it's taking that bottom end of the workstation space and giving you that kind of performance.
Quick question on that is, do you feel you have an issue?
If it's a server chassis, no. If it's a if it's a workstation chassis, yeah, you're going to have issues. You want to make sure there's thermal airflow. There is heat that's generated there. There is airflow constraints, so we work with the OEMs to make sure those airflow baffles are correctly moving across the boards on there. For server-based chassis, not today. We have that W9100 crazy card we spoke about. That's a potential to have something like liquid cooling in the future for servers if there's customer demand for that for oil and gas and visualization type needs. That's something we can do. The nice thing as well is you can actually take our regular W series and V series cards, so our mainstream workstation cards. You can take those and put those into server environments. We don't whitelist cards in our drivers. You can take any Fire Pro product and use it for VSGA, use it for VDGA, it'll just work. We're not saying you can only use these two cards on our approved list. These are just the server form factor cards. That's one unique differentiation as well. Because we're going to come across platforms like Dell Vertex as well, which requires passively, which won't work with passively cool cards, requires actively cool, because that is a really dense chassis that Dell delivers. You know, I don't know if you guys are familiar with the Dell Vertex chassis. It basically takes the Dell blades and has an I/O expansion plane. That I/O expansion plane doesn't have support for passive cards. So we can use any of our cards in that environment. And we actually have one of our active cards approved for that platform today, for that solution.
What about the heat that's generated on the passive side? Is that something that, obviously for a customer environment, we only use something like OpenCL, but is it something that it generates so much heat that you can throw that in a white box for evaluating?
No, you can throw it in a white box to evaluate. I just say, just make sure there's airflow in the chassis, in that white box. If you're really concerned about it, take the product name S9000, go get a W9000. That has a fan on it. Same exact card today. Yep, same drivers, same everything.
That's what I've encountered in my truck. You guys encountered that? That's been my understanding.
It's system vendor specific. So some of the system OEMs will say to us as a graphics vendor or to the other two graphics vendors, hey, we want to make sure your card has a manageability interface so we can get temperature off the card, so that we can know, okay, we're seeing a lot more power, we're seeing a lot more temperature coming off the GPU, hit the fans to higher speed so we can get airflow across the board, right? That's all BIOS, correct. Yeah. Correct. So we have to meet those requirements with an OEM. When we get a designer, this is why I don't have 17 OEMs on my list, because we're going through qualification right now, and Dell's out the door first, and there's other guys coming out the door, because we make sure our temperature type monitoring works correctly with their system BIOS so that there's no issues in a production environment.
Sizing utilities, what kind of cars you use versus we're not using 7,000, 9,000, even mid-market one, or not the mid-market, the mid-graphics requirement. Is there any kind of?
I'm working on a calculator for that. I'm working on a calculator for that. So we want to measure use case, look at cores on the system, because there is CPU impact to doing some of these solutions as well, and look at a better sizing tool. So I'd like to see us get a sizing calculator out. Whether or not we just throw it in a spreadsheet temporarily and get it to community, or if we put it on the website, TBD, but spreadsheet-wise, we can have something pretty quick for that. So it's something we're looking at. What we're validating right now is scalability on XenApp with some of the newest hardware that's out there. We have great numbers in Remote FX that Microsoft jointly did with us. We're just trying to come to terms of what is a good test to run on XenApp, what is a good test to run on like direct pass-through type modes and other shared graphics type modes. Microsoft's test is basically like a knowledge worker type suite with some 3D, but we want to look at different use cases and let you pick, okay, I got this type of use case on users, here's what the density is going to be, how many cards does that equate to? Okay. Very fast as well, we do a kind of unique product here. It's basically a GPU plus a hardware protocol encoder. It's got a PC over IP hardware encoder. And some of you guys in the virtualized space may have never seen the PC over IP hard encoder type cards, but significant traction in physical workstation customers. I'm talking oil and gas, I'm talking automotive and engineering type customers, more so enterprise, less so commercial and small medium business. But this product has pretty good traction. This, and also HP RGS have good traction in those customers who haven't moved to virtualized type loads. Interesting thing with this solution is it'll do full 60 frame per second support at 2K resolutions. It'll remote up to two 2K displays. It'll remote to PC over IP0 clients or soft clients. It can be brokered with Horizon View, and this does support direct pass-through. So we have one system OEM for specialized workstations, Box Technologies, that's shipping this solution with 4 cards into those customers who don't necessarily want to have all the VMware Horizon View broker infrastructure. They just want to leverage the hypervisor and then leverage the PC over IP remoting capabilities. You can still use Terra 1, but it goes to a degraded mode. Yep. Okay, so just some key highlights about what we're kind of working on. We're really trying to get ISV certifications out there for virtualized platforms and for virtualized application type platforms as well. You're going to see a big initiative from us over the next 90 days to get ISVs to accept the delivery of these applications under virtualized type platforms. We're starting to work on how to monitor GPU beyond just basic, give me the GPU performance. Can I look at how is that GPU in a shared environment or a session type environment behaving? Other thing we're moving towards as we do our mid-year refreshes on some of the products, we're going to larger frame buffers for shared graphics. We're starting to see certain hypervisors that have limitations on how much graphics memory they can support, starting to lift those over time within the VM. And then we also continue to do enhanced APIs for remote protocol display. This is affecting guys like Citrix, VMware, and everybody else like that, making sure they can capture our graphics display well and have some performance takes into there. And I'm not going to go into too much detail on this. I know Intel announced something at Synergy. We have similar technology coming out for we're calling it multi-user GPU, in that it's a true GPU. It'll allow multiple users to use that, multiple VMs to use that GPU technology. It comes off of one session, and effectively it doesn't require any software stack in the hypervisor. We're doing a very different approach. We're hardware abstracting a single GPU to look like multiple GPUs in the VMs, so that there is no stack that has to be ported when a new version of the hypervisor comes out or a different hypervisor comes into play. Very different approach. We've been very quiet on it, but we're going to start nudging some more information out, give a different approach, and that will again bring some competition in the market, because we're going to focus on high end. Intel's going to come in at mid-level, going a little bit up. So you're going to see some interesting things coming out on our side. And then conceptually, we're looking at 5-6 years down the road, taking the APU technology that we have, how does that play in the data center? So we're starting to look at those areas as well, is how do those low power CPUs, how can they play into server type use cases with our OEMs? So that was kind of it from my side. I would just love some feedback on who today has done deployments with customers with GPU technology. What are you finding as the struggle points today on that? Go ahead. Okay, so like if it's CPU heavily using CPU and GPU, you're finding a misbalance on the application, or?
When this is all good CPU, you want to do it immediately, right?
Okay, got it.
That's a problem.
So what do you think needs to be there? Better monitoring, so you can elaborate when someone's using the application real time. Hey, is it hitting the GPU right now? You want better monitoring, or what do you think's Yeah. I think one thing we've come across as we've been playing around with scalability is I can do a GPU that's really can go crazy on how many users it can support on our future roadmap. The question is the platform still have enough horsepower from system memory and CPUs to deliver that set number of users? I mean, you're taking a beefy workstation that's normally single socket, 8 cores minimum, and you're telling, the math is not right. You can't take a use case of a physical workstation like that and take something that's maybe got twice the number of cores and go do 5 users on it. You're not going to get that same kind of performance, right? So there is a mismatch there on that type of user.
One of the biggest challenges for nesting is actually taking it from the assessment period, having a proper solution, then the workflow
Okay.
like monitoring something here on CPU, memory, disk, I/O, those types of things. Well, there's nothing that's currently available that does it at scale. When you talk about hundreds of users in a GPU environment, the dashboard type of look, you get access to it.
And you want that to go across all the GPU users, so not just one server, all the servers deployed.
It's not your guys' problem. This is a monitoring infrastructure problem.
Well, we want to make sure we're at least exposing that data. So if the guys like Lakeside or anybody else wants to take that data, we want to make sure we're giving them the ability to grab that data from the GPU. So that's one area we're addressing is performance metering, making sure we're putting the right things out on our side. One other thing is what's really key on the workstation space today, if you're going into customers and you've not been in the workstation space and you've been more focused on traditional VDI, is end device performance. That is key. Don't underestimate the client device performance. I'll see some customers pick like a single core CPU with thin client and they'll go, oh, it'll do great. And I'm like, there's no physical way on HDX or PC over IP or any other protocol it's going to get great decode performance with a single CPU type implementation. So just be really cautious. Look at end to end. If you're putting this really great solution in the data side back end, look at the front end clients as well. Make sure they can deliver the decode performance that's needed to make those users feel like it's their workstation. It shouldn't feel remoted. If it feels like it's remoted, you've not delivered the good solution to that customer. They should feel like, I mean, we've actually had customers in my previous life when I did remote protocol switch users without telling them. They keep their PC on, they'd hide the client device behind the system and they'd see, did they notice? Yeah, the people would notice. Some of the users would not notice. They would just say, hey, it's behaving a little differently, but it doesn't seem like it's slower. My data set loads are happening really quick. Did you guys change something? Because now obviously your virtual machine is sitting in the data center where your storage is. So there's benefits, but totally don't underestimate client device selection. And we do client device ASICs, AMD does as well, but we also work with guys like Teradici who does the zero client silicon as well. And then we also work on what can we do on our client device chips for the future so that we can do better decode on those type of devices as well. We're looking at client device now to be not so much commodity as what features can we put on those client device chips to make sure the decode stacks look good as well. Any questions on anything? Sure.
So one of the challenges that we see is that we standardize on certain hardware, and so many of these brick cards are not flexible to hardware. So I think that as these become more common, we need to be looking at partnering more with these companies so that there's more flexibility in options. So, because I want to use these cards,
Sure.
but they don't use my
And is that because the server vendor doesn't meet the server vendor standards, or what?
Well, I think that, servers that we use.
Okay, so one education path we're going down with the system OEMs is, guys, you don't need to pick this 150 to 200 watt card. We have 45 watt cards. We have 75 watt cards. One or two of those per system can meet the performance of some of these really beefy cards. It doesn't require them to requalify anything on their platform. They're passively cooled, very low power. Even in an open chassis, they're not going to overheat. So we're going down the OEMs with alternative solutions of exactly what some of you guys had hit in when we first walked in is, how do I go enable GPU on knowledge worker type users, not just on these workstation class type users?
For all of the form factors,
Yeah, so we have a MES option that is coming out with one of the tier 1 OEMs shortly. We do a MES type card. It's an MXM mezzanine card, so it'll work on any vendor who has an MXM type solution. I'm sure you could assume who that is, but there's also a second vendor who's going to be coming out with an additional solution in that. And then we're also looking at, can I take those MXM type cards? Can I work with third parties who do those PCI Express type risers? Can I get 2 of those cards or 3 of those cards onto a solution and deliver something to an OEM that's very low power as well from that point of view? So there's a place for vGPU. There's a place for these vGPU or multi-GPU type technologies. There's a place for shared graphics type technologies that are going to be both cost effective and low power. And then there's also going to be a place just to continue direct pass-through type graphics. If you look at direct pass-through type graphics today, most of those direct pass-through type cards, I'll be honest with you, a 45-watt card is good enough for direct pass-through. You are delivering blazingly fast performance compared to what you'll get on a single, if you split a vGPU into 4 users, you're looking at something that's still very comparable at 45 watts. So that's still a good use case. All right. Thank you, everyone. All right.